idea. Many triangles are not right triangles. And you remember before that if you have a right triangle, that you can solve right triangles by doing this. Remember that? Remember doing that SOHCAHTOA thing? Okay, where angle C was always 90 degrees. This one we don't get a 90-degree angle, and it sounds like it'd be really, really, really bad. But it's not that bad. It's not that bad at all. This is something that we can do. Okay? So the other thing you can do with right triangles is the Pythagorean theorem. But here we won't have the Pythagorean theorem because we don't have right triangles. So on your test, I'll actually give you some right triangles to practice just for old time's sake. Then I'll give you some non-right triangles. And the only thing that's kind of challenging is how it's all set up and how we kind of start to understand. I want you to take your notes. I want you to look at the very last page of your notes. And it looks something like this, right? This is the sheet of notes that you get to have on your test. I want to be clear. I don't pretend for a second that this is perfect as to how I put this together. The people who are able to read through this and understand it generally do very well in the test. Sometimes people say, I can't understand that. My response is generally, okay, try to put together your own, and we'll see how that works out. And usually, they aren't able to put something together that really navigates through it. This happened over the course of about 3 years. I saw students that were in this unit, and they didn't know what to do when. And so I started to put together a flow chart. And I said, well, does this work? Does this help you understand? And a couple students were like, yeah, that helps me. I think I get it now. And a few were like, no, that still doesn't really work. So I go home that night, and I try to make another one. And I come back. They're like, okay, it's better, but I still don't understand this part. Finally, I came up with this one, and everybody in the class was like, yes, this works for my learning. The fact is that when I started teaching math, that said, this is the sheet of paper that you'll get. We're going to go back and we're going to discover the law of sines. And we're going to start by saying this is angle A, this is angle B, and this is angle C. Now, from what we learned in the very first part of our trigonometry course together, this would be side A, right? So what would this side be right here? B. And this one is side C. Now, I drew a right angle. I drew a height, an altitude. I'll call that H. And I'm going to use that. What I would like to do is come up with a formula that relates some angles and sides together that doesn't involve H. I'll write one down so you guys can see what I'm saying. Okay? The sine of angle A is equal to the opposite divided by the hypotenuse. Everybody agree with that statement I just wrote down? The problem is that in a lot of these triangles, we wouldn't be given the height. So suppose they took that away. What would we then be able to say about that would be important? Okay? Well, I'm going to actually use that statement. I'm going to say that the sine of angle A is equal to H over B. And I'm going to say that the sine of angle B is equal to what? Can somebody look at angle B and tell me what the sine of angle B would be? H over A. Good. What do both those expressions share in common? They both have an H. So what I'm going to do is I'm going to solve for H. In order to solve for H, I will multiply both sides by B. And I get B sine of A is equal to h. And for this one, I'll multiply both sides by a. And I get a sine of b is equal to h. Right here, so we are talking about the side. If they're both equal to h, then they should be equal to each other. So I can write b times the sine of angle A is equal to a times the sine of angle B. Now that's almost in the form of what we call the law of sines. Here's one last thing I need to do. I'm going to divide both sides by AB, and you can see what happens. If I divide both sides by AB, what goes away here? The B's, and what goes away here? So I end up with this equation. The sine of angle A divided by side A is equal to the sine of angle B divided by side B, which is actually equal to the sine of angle C divided by side C as well. That's called the law of sines. And it's really, really, really important. It's helpful. It's good stuff. And it's easy to remember, isn't it? That's part of what I love about it. Sine of A over A, sine of B over B, sine of C over C. But as you look at it, there's something important that you have to understand. Sine of angle A divided by side A. Sine of angle B divided by side B. Sine of angle C divided by side C. So really what you have is you must be given an angle and its opposite side. So the law of sines works for a lot of triangles, but only for triangles if you're given an angle and its opposite side. So let's try solving a couple triangles here. This is what you're going to be doing during this entire unit. I'm going to write A, B, C, little a, little b, little c. I do A right here. Angle A is 42 degrees. D, 80 degrees. And side A. 10. You found angle C. We'll do that in a second. Okay? So this side is side 10. Now, I know that you know how to find angle C, but before you do, let me first work with you on classifying the triangle, okay? We have to decide which one of these 6 situations it meets. So I'm going to look at my file here, and I want to decide which one of these 6 it is. How many angles are we given? And one side. So therefore, it's either angle side or angle side angle. Which one is it? Exactly. I would say that generally speaking, about 50% of students, even though they took geometry, they don't know this part. And this is what's so important for you to focus on. This is angle side. No. Here's what you do first. You look to see if the side is between the two angles. For example, suppose that the 10 was there. Is the side between the two angles or outside the two angles? It's between the two angles, right? You have 42 and you have 80. 10 sits right between them. So that's why they put the side between the two angles. Your teacher taught you that. Your brain wasn't ready for it. All right. Yeah, so it's something that we just didn't quite get, but does that make sense now? Okay. So that's something important to know. All right. So what I do is I go to this sheet, and again, because I'm teaching you how to read it, it's an angle side. So I look down and it says there's only one solution for this triangle, and I use the law of sines. Great, that's good news, because sometimes we come up with one solution. Other times we come up with no solution, and other times we come up with two solutions. So when it says one solution, that's good news. We're very happy about that, and they're easy to solve. And so that's what we're going to do right now. Let's solve this. Now, Nathaniel, you got angle C. What did you get angle C to be? 58 degrees. How'd you get 58 degrees? All the angles have to add a 180, right? Is everybody okay with that? So now we just have two more sides to find. What I'm going to do is I'm going to use the law of sines. That's what it said. My sheet told me if I have an angle side, I can use the law of sines. Because I have an angle and its opposite side. So I will say the sine of 42 degrees divided by 10 is equal to, would you like to find side B or side C? It's up to you. B? Okay, we'll do B. So I'll do sine of 80 divided by B. I will cross multiply and solve. If I multiply these two together, I get B times the sine of 42 degrees is equal to 10 sine of 80. How do I solve for B? Yep, I'm going to divide both sides by the sine of 42. So I have B is equal to 10 sine of 80 divided by the sine of 42 degrees. So there's no way I could do this without having my calculator. So I go ahead and grab my calculator. Hopefully it's charged up. Here we go, calculator. There it goes. Mode. Need to make sure that I'm working in what? City calculator is a little angry. Okay, let's try again. Mode. Okay, I want to be in degrees. And for this unit, you'll be in degrees the entire time. And I take 10 times the sine of 80 divided by the sine of 42. And I can type it in just like that. It's very important that you put the parenthesis after the 80. If you don't have a calculator like this, you'll have to figure out a decimal for each one and then divide it out. Press enter, I get 14.72. We'll round to the nearest hundredth in this unit. 14.72. Now I'm going to try to find side C. A lot of people go back to the Pythagorean theorem. Only the Pythagorean theorem only works if we have right triangles. So therefore, we cannot use a Pythagorean theorem. We will simply just go back and use the law of sines again. I'll take the sine of 42 divided by 10 is equal to, now what side are we trying to find? So I'll take the sine of 58 divided by C. Can't do a squared plus b squared is c squared. That's the Pythagorean theorem. It only applies to right triangles, and we do not have a right triangle. Therefore, it does not work. But we'll use this, and we get c times the sine of 42 is equal to 10 times the sine of 58. Divide both sides by the sine of 42. C is equal to 10 sine of 58 over over the sine of 42. Now, does anybody have a calculator like mine? Okay, I'm going to show you a really quick way to then do this problem. Because it looks really similar to the previous one, doesn't it? Okay, the only difference is instead of an 80, there's a 58. So I could press second entry. Come on. Second entry, and it brings up my previous entry. I could just go back and change that 80 to a 58. And that will then give me 12.67. That's a nice quick way to get your calculator to plug in what you need. And now the last thing I'm going to do is I'm going to check my answers. Okay? As you look at this, what's the biggest angle? 80. Does it have the biggest side? Yes. What's the smallest angle? 42A. Does it have the smallest side? So that's part of what you want to check. As long as you do, you'll probably be good to go. Not too bad, huh? Let's try a couple examples on your worksheet. Let's try this one. We're going to solve triangle. We'll do example 1 and example 2 together. I'm going to draw my triangle. Whoa, that always happens. Okay. A, B, C. I don't have as much room as you guys do because, you know, the ink is just larger with this thing. So I've got A is 85, so I might have to go off the screen for a bit. 32. B is 20. B is 32. A is 85. B is 20. Can somebody tell me what kind of triangle I have here? How many angles do I have? 2, so it's either angle, side, angle, or angle, angle, side. Those are options. The question is, does the side sit between the angles or outside the angles? The side sits outside angles. If it sat between, it would be sitting here. So it's an angle, angle, side. And so our decision tree tells us that there is just one solution. So we can be confident that we'll get this one figured out without any issues. So what's going to be the easiest way to get started here? What should we find first? Okay, let's find angle C. What is angle C? How do we find that? (180 minus 85 minus 32), and I get 63 degrees. Now I have two sides left to find. Forrest, you wanted to find side A. Side A is a good side to find. So we would take the sine of 85 divided by A. That's our unknown. Is equal to, now I need an angle and its opposite side that I do know. Sine of 32 over 20. We'll cross multiply. 20 sine of 85 equal to A sine of 32. I divide both sides, I get 20 sine of 85 over the sine of 32 is equal to A. Did you guys do the law of sines in your geometry class? I think they're actually starting to build it in right now a little bit. So 20 sine of 85. Make sure you close that parenthesis divided by the sine of 32. And I get 37.60, we will call. Does it make sense that that side is bigger than 20? Yeah, it does. Good. All right, let's do the next one. How do I find angle C? What should I set up? Sine up. 32 over 20, that's fine. Is equal to, Rachel, you said sine of 63 then, over What's opposite angle 63? C. So you can write, if you want to write the sine of 63 over C first, that's fine. It'll still work out the same. We cross multiply, we get C sine of 32 is equal to 20 sine of 63. What should I divide both sides by? So I get C is equal to 20 sine of 63 over sine of 32. Again, I'm sorry that I have so much here. I can't write nearly as small as you guys can. So 20. Oh, I'm just going to cheat. I'm going to do second entry. So I have the same thing up there. I just need to change it 85 to a 63. So again, that's one thing I'm going to do. I think you guys can actually get a TI-83 on your calculator. I think it's like a $5 app. I'm sorry, on your phone. Okay, did that work out? Okay, all the problems on the right-hand side are going to work out just like that, okay? And I have a total of 10 problems. You're going to do just 8, okay? You're going to do 4 like that, and then you'll do 4 on the other side. We're going to try a different one now. Can anybody see just by looking at what makes this problem different? 2 sides. This is where things get a little bit more complicated, but we're gonna stay nice and simple today. We have A, B, and C. This is 40 degrees, and then side A is 10, and side C is 7. So I'll write that down. I've got 40 degrees. I've got C is 7, and A is 10. All right. Now, how many sides do I have? 2. So it's either going to be side, angle, side, or it's going to be side, side, angle. Yeah, if I was given, okay, if I was given the 40 degrees right here, then it would be side, angle, side, because that 40 degrees would be sitting between the 2 sides. But it's not sitting between the 2 sides. So look at it right here, okay? Side, side, angle. That's the one we're given. And what you'll end up doing is you'll go down here and you'll answer this question. Is the side opposite the angle longer than the other given side? Or is the side opposite the angle shorter than the other given side? And we're just going to do one like this today. It's not a big deal. But here's what we look at. Is the side opposite the angle longer than the other given side? Or is it shorter? Longer. All the ones I give you today are longer. And that's good news. Because if it's longer, then there's just one solution. And we can just solve it like we normally would. That doesn't happen, then things get a little bit crazy. Okay? So let's try this, okay? We can solve it using the law of sines. I'm going to set it up. Sine of what? 40 divided by 10 is equal to, which angle are we going to be finding? Sine of C divided by 7. I cross multiply. 7 sine of 40 is equal to 10 sine of C. What do I do now? Divide by 10. And I get 7 sine of 40 over 10 is equal to the sine of angle C. I get 0.4499. That doesn't sound like an angle. Do you remember, if you're finding an angle, do you remember what you press on your calculator? Inverse. Remember? That's the difference. All the ones on this side don't require inverse because you have the 2 angles. This one, you're trying to find an angle. So when you get to that spot, you get that 0.4499. What you do is you go second sine inverse, and then you type in that decimal 0.44995. And Raquel, you made a very good point. This is a good time to check to make sure that you're not working in radians, because maybe your calculator is working in radians. But in this case, it's just the fact we need to press sine inverse. And we get 26.74. Does that sound like a more reasonable number? So angle C is 26.74. Well, now that I know angle C, what can I do? We're already done? No, 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 no. It's it's yeah, it is 159. Okay, well, so yeah, you would subtract. Let me just do this one part. 180 minus 40 minus 26.74, and you get that 113.26. In order to find B, just set up the law of sines. Okay, just set up the law of sines.